Hello, everyone, and welcome to part one of my CNC build adventure. I don't want to say that this is a guide because many things are going to change as we go throughout this process and make some changes and additions. Let me first run through the main objectives of this CNC build. The first objective is to do wood CNC routing and shaping, for things like cutting boards or cribbage boards and other various signage, things like that, just as a way to get a little bit of income here and there while working with wood, but also the ability to cut some wood, flat wood shapes for fit together parts and shelving and things like that. Um, that's one of the primary uses. Two secondary uses, which are kind of more stretch goals for this project, which I think the first one was easily achievable, which would be some sheet stock aluminum milling. So we're not talking large aluminum blocks. We're talking about sheet stock, up to 5 or 10 millimeter thick, of course, with several passes, would be one of the goals. And the last goal, which it's kind of a stretch, and it may require some late adjustments, in 6 months or a year or so, with primarily the upgrading of the spindle, and that would be to try to go after steel, mild steel um, sheet material for cutting steel shapes, for forming things like that. So cut out flat shapes and then take them out and either use them for other machines or potentially do some forming with like manual hand brakes or things like that in order to create other parts. As we can see here, it is a Cartesian style design. We have an x-axis, and so here's our x-axis gantry here. And so this, oh, hold on, let me grab this here. So these will move our x-axis, and if you're already paying attention, we have a dual motor y-axis. Now you'll see a handful of stuff still missing from this, and hopefully with my part two update, all of these will be included, but we are going to have the motor mounts either here or on the back side. I haven't determined which side I'd like to mount. I'm thinking the motor's on the back side, so I have nothing sticking out the front would be nice. And then of course I'm going to be using a ball screw through here. Now, in addition to the X and Y axis, we do need a Z axis, and I haven't actually designed that yet, but it will probably be very similar. In fact, this gantry for the X-axis and the Y-axis gantries are the same exact one. I'm foreseeing the need maybe to change some of the design up here. I may have to exclude this and go right to the 80/20 from these mounting plates here, but I'm not sure yet. Some of the things that I'd like to address are the fact that I don't have ready access to a CNC mill or a laser cutter without spending a decent amount of money. It's not something I'm looking to do. So these plates in the front and the back for the stepper motors may be cut out of plywood and drilled out just out of some wood, or maybe if I have some maple or oak lying around that I can use, because those might be rigid. I might make those out of some of those and do printed templates, trace them out, cut them out, and do hand drilled for the holes. Of course, that doesn't really give us good precision. I can use my drill press, but it's not going to really give us precise measurements for where everything goes, and we may end up with some binding or some other issues if those aren't good, as well as the side plates. If we don't have all the holes very accurately drilled out, it could cause some skewing in future parts that we make. So if we go that route, um, the best option for us to do would be to try to do any sort of software corrections for skewing if possible. I've done a lot of 3D printing, and I know some of that correction is available on 3D printing controllers. I'm not sure about CNC. And the other option that I have for this is to either order some parts, which I may do eventually, but these front caps here, I do have access to my 3D printer. Once I get that running again, I can 3D print these end caps. It doesn't help me with the side plate though. You'll also notice there aren't any holes in the side plate. That's because I'm not done defining where these holes need to be, um, and the mounting holes for the gantry here. No. Oh, that's interesting. These are not. Oh, I'll have to look at that later. Maybe I just rebuild it. Nope, these are supposed to be mirrored, so they should be in line with that. For some reason, they're not. Yeah, for some reason they're not. They're not mirrored. Anyway, not properly anyway. Okay, so looking here, um, this design here with the two linear rails and the lead screw down the middle is going to be the same that we're going to use for the Z-axis. Now, just because of lead ball screws that are available off the shelf, I'm looking at potentially doing like a 600 millimeter version of this, which is, you know, probably a lot larger than it needs to be. Hold on, because that's about 23 inches, which is just absolutely ridiculous. You know, for that, and I would have to find a good alternative option for a lead screw or for a ball screw. Um, and I'm not sure if I can. I don't think I can actually cut down a ball screw to length, um, even if I find a buddy of mine. I have to look more into ball screws and if there's restrictions on the actual screw itself, if I can just cut it down to size or not. If I can, it'll be too easy. We'll just take it, I'll bring it to our buddies, and we'll cut it down and put everything back together. So that's my only challenge right now is looking at primarily the Z-axis, and then of course just modeling and putting in my ball screw um, models here. Um, and I think that should do well enough for me. And long term, after we get this thing up and running, I hope to make this part and these mounting brackets out of a machined aluminum right on this machine. And if we can upgrade these parts to aluminum, then they'll be pretty strong. I don't doubt that after we get this thing beefed and upgraded with aluminum, that we will have any issues with getting up to being able to do steel. Um, you know, it doesn't look super rigid. This is Open Build's V slot. These are these are 20 by 40 millimeter aluminum extrusions. You can see the profile here. They work well if you want to use any um, V wheels that they offer for this setup, which I'm not opposed to. I'm just contemplating if that's the route that I want to go for anything. I much prefer these linear rails. I think they're very solid, and once they're well lubricated and you take care of them with maintenance, they hold up for quite a while. Especially with the ball screw, I think that'll be the easiest way for me to go instead of having to rely on the wheels to stay in shape and deform over time. I think with higher force, with potential steel, I think these are the better option. However, the aluminum extrusion is still great. I might be able to save some money by going to 80/20 aluminum extrusions, but I'd have to look at the cost on those, and I think the V build is actually cheaper right now. Um, some other points of upgrades that aren't shown here that will later up show in maybe an upgrade video is I plan to, once I can do some um, aluminum, I have to figure out how I can just do like a half part routing with a little bit of a indexing, and then rotate and flip a piece of sheet stock, because I would like to make plates for this whole section here and the whole section on top. That should help make things a little bit more rigid, going all the way around the back with one frame piece as well as the back here. I think that will help significantly. And also on the side motors, it'll help keep any debris from going out into the ball screw. Unfortunately, I don't have a debris prevention plan for the upper section of the CNC. As far as a spindle, you probably saw this page flash up earlier. There's actually a group which I will plug here. It is Print NC, and Print NC, they have a similar but a little bit different. Their goal is to do tubing. So get metal tubing, 3D print some parts, slap everything together, and boom, you got a CNC router slash mill. And these are actually pretty good. They're rigid. You can actually see on their site they have some things for like machining. I think there's a video of a guy machining some steel. That's how I found out about this. On YouTube and through the Hobby CNC subreddit. Um, By the way, also, I do have to give credit. My design was heavily inspired by a machine that I saw on the Hobby CNC Reddit. Um, and this, obviously, you can tell it's almost an identical build, right? Um, there's hopefully gonna be a few things that I'm looking to change. Obviously, I would like to approach it from a different type of design compared to his, where his has this heavy metal pieces, and I can't remember. I haven't seen the previous one. I think he said that he had some wood here before, um, but I don't. I would never want to have these, uh, nuts sticking out the end from these bolts and some things like that. But this is kind of where I started, was with the design very similar to this, um, and so I did a lot of research, a lot of looking around. Now the 3 Design Store from Print NC Group supplies a relatively affordable $400 kit that includes um, the. It looks like it includes. It might not include everything. I might be missing some stuff. So it includes. Is just this $400 kit is just the spindle. So it's the spindle, the variable frequency drive, that VFW, or as they call the inverter. This has a spindle clamp, and this is a 2.2 kilowatt inverter and 2.2 kilowatt spindle. The other guys that I showed you his design, he was using a 1.5 kilowatt spindle, and he was able to still do steel with his in the design that he had. Now these are ER20 collets, which is pretty common. And those should be plenty for all we're looking to do here. And then this also has a water pump and water pipe. What this doesn't include, which is some of the other ones, has so here's the motor kit. So this is gonna be something else we'll probably purchase. This is a DM542 driver. It's got the power supplies, has the Mach 3 breakout board. Um, and so that DM542 driver is this part here. So that's a stepper motor driver. So those will connect to here, and then the Mach 3 breakout board. What that'll do is that'll allow us to talk to Linux CNC or Mach 3, probably Mach 4 software as well. And what that does is send the stepper motor direction and pulse distances. I shouldn't say distance, but edge pulses to control these motors. And so this is a full motor kit, and these are 57 HS100. These are the stepper motors. So I presume that they're probably similar to like a NEMA 23 stepper motor. I have to look at the specs on this. My design, I was intending to go with the NEMA 23, but if this is available as a kit, I'm looking at now 250 plus give or take about 400, so I'm looking at about $650 all in. Now they do sell for the Print NC a kit, and with this kit you have a full assortment. You can get either a 220 or a 110 volt version of the kit, and you have a full assortment of different items, which include linear rails, some end stops and probes and things that I'm going to have to buy on my own, as well as cable chain. Um, those are all very handy things, but the problem why I can't use this kit is because of the dimensions that they would like you to use for the build. So with that build, you're getting 250 millimeters travel height, and you're getting 700 millimeters in one direction and 1100 millimeters in another direction. And if you look at this build, the actual build area here, um, in each axis is each gantry is 1,000 millimeters. So I would lose. Right now, I'm at about. I estimated, so this is about 36 inches across from here to here. Um, I believe. Maybe it's a little less. Yeah, about 36 inches from there to there. And after I center out my X gantry with where the spindle will align, I'm only going to have I'm going to have about 32 inches wide. And because I want to do some larger pieces, this will inhibit me from being able to do that if I want to drop down to 700 millimeters. Now 700 millimeters, I'm dropping down, um, like 200 millimeters, or give or take around like 7 inches, right? And so, I don't want to give up I don't want to give up that much space in my X axis, though I could. Um, I guess I'm going to price things out and see where it sits because um, their total kit is 1,050. So what I would have to do is I have to source the linear rails and the probe and the ball screw kits. Um, I need to be able to source all of those and my end stops for around $400, which I think I can. And I was looking at other spindles and other items from another vendor at Vivor. Of course, this is way much more in the cart, but let's take a look here. You can see they have some linear rails with ball screws, so it comes as a kit. However, they don't have a 250 millimeter um, version. They only have a 600 millimeter version, and so this is for my Z axis. Now they do have the 1,000 meters that I need, but by the time I get my three kits, that's already almost $400, and that's not counting getting any of my additional end stops or endpoints. So I think if I get the end stops and the probes, we'll be sitting at around the same price. So now it needs to come into: am I willing to give up um, in order to use this one kit? Am I willing to give up all of the um, space on my x-axis? Um, And one thing that comes from giving up some of the space is a little bit more rigidity. So it should be more likely to do um, a little bit of steel. So, that's in summary kind of where I'm at. So I'd love to hear some recommendations, any sort of advice or questions that anyone might have about this DIY CNC planning, um, because I'm just getting started, but it's a very exciting project, and I look forward to showing everyone progress as we go on. Thank you.